Okay, so welcome back. And now in this video, we're going to talk about similar figures, but this time we're going to apply it to looking at houses and shadows. Okay, so let's say we've got the sun here and we've got a shadow that's 8 foot long with a person who's 6 feet tall. And so a person 6 feet tall casts a shadow that's 8 foot long at a particular time of day with the sun. And at the same time, we've got a house that is 15 feet tall that's casting a shadow with the sun. Again, let's say the sun's here, but at the same time, right? So the angle is pretty much the same. And we want to find out what the length of the shadow is for the house. So we're going to use similar figures. So in this case, similar triangles, because this creates a triangle with the height of the person and the length of the shadow all the way here with the rays of the sun. Okay, so we get a triangle here, and then we've got another similar triangle here. So can we use similar figures and use that to set up a proportion to find out what the length of the shadow is? Yes. So let's do that. So corresponding sides are equal. So let's do that. So we're going to take 8 and correspond that to S. And we're going to equal 6 corresponds to 15. Okay. Now, could we have done this differently? Because here the S is on the bottom. Well, that's okay because we're going to cross multiply, right? We're going to cross multiply. We get 6S equals 8 times 15, and then divide both sides by 6. But could I have done this way? Sure, I could have set it up S, oops. S goes with 8 equals 15 goes with 6. And then just multiply both sides by 8 and I get the same thing. Okay? So again, I could set it up this way or I can flip it. As long if I flip one side, just make sure you flip the other side, right? Whatever you do to one side of the equation, make sure you do the same thing on the other side. So in this case here, if I solve for S, right? So S equals what? Well, this is going to end up being what? 5 times 4, which is 20. Okay? Because 3 divides the top and the bottom here, so this would be 8 times 5 over 2, but then 2 cancels with 8, which gives us 4 times 5, which equals 20. Okay? And so the length of the shadow of the house is 20 feet. Now, normally I wouldn't do it this way. I thought it was odd that the problem was set up this way. Normally, we would like to estimate what the height of the house is, at least from here to the height. So one way we could do that is measure the shadow to where the chimney is here, measure out from where the chimney is out to where the end of the shadow is, because we want to use similar triangles to find the height. But again, this way we were looking for the shadow. So again, for example, if I wanted to estimate the height of a tree, right, I could use my shadow and my height and the shadow of the tree and do similar triangles and use a proportion to estimate the height of the tree without actually measuring it. Okay, because it's a lot easier to measure the length of the shadow of a tree than it is to measure the height of the tree. Get it? Okay. Have a great day.